Then we are going to talk about, I've elaborated on artificial and natural radioactivity. And the major difference is that this one is induced, it does not occur spontaneously, while this one occurs spontaneously. And also, I would also like to talk about the applications of radioactivity, because radioactivity has diverse applications which are of significance in medicine, industries, agriculture, and the likes. Then, one, medical uses. Gamma radiation is used to destroy cancerous growth. Take note of that. We use gamma radiation to destroy cancerous growth. Then, in sterilization, gamma radiation is used for sterilizing surgical equipment. We use gamma radiation to sterilize surgical equipment. Industrial uses. Beta and gamma radiation are used to monitor and control the thickness of sheet materials. We use it to monitor and control the thickness of sheet materials. Then also in agriculture, agricultural purposes, to induce mutation. What is the meaning of that? That is modification in the what? Genetic constitution in plants and what? Animals. So we also, radioactivity also has its application in agriculture in this respect. And also, radiation is also used in insect and pest control. We normally use radiation to control pests and insects. Then radioactive tracers. The movement and behavior of a radioactive atom can be traced because it emits radiation. And simply, when a radioactive substance emits radiation, what are those likely radiation you are going to get? We have alpha particles, we have beta particles, and we have what? Gamma radiation or gamma rays. Let me say gamma rays. So then I'll be talking about this, but let me settle this first. Then I said radioactive tracer. So I quickly mention this because it will help us, because this one is positively charged, this one is negatively charged, and this one has no charge near. So if you want to use radioactive tracer, if you are bringing a negatively charged species around that particular radioactive atom and you have attraction, automatically you know that it must definitely be a positively charged species. That is, if you are bringing a negatively charged species close to it and you can feel attraction, then you will know. But if you are bringing a positively charged species and you have a repulsion, you definitely know that it's a positively charged species. That is a way of using radioactive tracer to trace a particular movement or behavior of a radioactive atom. Then also dating techniques. Radiocarbon dating is used to determine the age of the more recent organic remains found in archaeological excavations. So we normally use that also to determine the age in more recent organic remains. Then also, let me quickly talk about when an atom or radioactive substance decay. Alpha particles, beta particles, and gamma rays will be emitted. Properties of alpha particles. 1, they are positively charged. 2, they are fast moving stream of particles. 3, they have the highest ionization energy. 4, they are deflected strongly by electromagnetic field. 5, they have strong penetrating power. Then in the case of beta particle, they are negatively charged. They have fast moving stream of what? Electron. They have a moderate ionization energy. Their penetrating power is less compared to that of alpha particle. They are also deflected by magnetic field. Then they have a lower ionization energy. Their penetrating power is the weakest of the three. Take note of that for beta particles. Then in the case, they are fast. Another one that I need to mention is that they are fast moving stream of electrons. Then gamma radiation. Gamma rays, they have short wavelengths. They are electromagnetic radiation. They have the highest penetration power. They have the lowest ionization energy. They are not deflected by magnetic field. These are the properties of these three radiations emitted when the nucleus decay. So these are the UTME questions structured for this particular topic, nuclear chemistry. But before I go into the questions proper, I will also want to use the opportunity to quickly explain the simple equations involved in nuclear reaction. Just like what you have there. One thing you must note is that if you are having A going to B, for example, as far as nuclear reactions are concerned, the mass, the atomic mass or the mass number must be the same. Must be the same on both left and right hand side. So what I'm saying is that if the mass number here is X, here it must be X. If the atomic number here is Y, it must be Y. The mass number on the left hand side must be equal to the mass number on the right hand side. The atomic number on the left hand side must be equal to the atomic number on the right hand side. And you know, for our alpha particle, which is known as what? Helium atom, He42. So if you are going to have alpha decay, if a species having, let's say, XA, B, you have a species such that their mass number is A and the atomic number is Z. If it's going to exhibit alpha decay, automatically what it simply means is that your A will be what? Decreased by 4, and your B will be decreased by 2 once it has exhibits that what? Alpha decay. Because A minus 4 plus 4 will definitely be equal to A. And that was why I said that as far as nuclear reactions are concerned, the mass number on the left hand side must be equal to what? The mass number on the right hand side. So that means if this one is going to experience or undergo alpha decay, the mass number will decrease by 4, the atomic number will decrease by 2. Then also, because B minus 2 plus 2 is also what? B, which is this. Then also for beta particle, then if it is beta particle, instead of having a decrease, there will be an increase. Let's see, A, B. So in this situation, we have X will now be A, the atomic number will increase by 1. Then we have plus, because our beta is electron. So that's our beta. So you can see now, this one, A plus 0, A is the same. B plus 1 minus 1, B plus 1 minus 1, that's definitely what? B. So you can see that they are also the same. While for gamma rays, it does not change, it remains the same. In the sense that when you have XA, B, if it's going to experience gamma ray, then it will definitely be BA. So you have something like near. So because with gamma ray, you still have any species that you are going to have. Let's say, let's use probably y, for example, is 0, 0. So there won't be any difference in that. So take note of this fact. And also, I want to also use this opportunity to explain half-life. I said half-life is the time taken for half the mass or the amount of the radioactive elements initially present to decay. That's half-life. So if, for example, a species X decay by n in 10 years, and the question asks what will be the fraction of the decay in 40 years time. So what it simply means is that, so what the way you are going to write this one is to say n in 10 years. In 10 years. So in the next 20 years, you know it's half of the original. So since this is the original, it will be n times 1 over 2. So that's what you're going to have for 20 years. Then for 30 years,